So let's shift them.
You should have recorded that.
Yeah, it's a good thing. That's why we don't have video. Shifting. Basically, what we're doing here today, guys, is just adding the H and the K.
Oh, should we write down that?
Yeah, we're doing everything like we did yesterday. The values of A, B, and C are all still the same. The only thing that changes now is the fact that we're going to have an H and a K, a horizontal and a vertical shift to where our center will lie. As we walk through them, we have our ellipses are x minus h quantity squared over x squared plus y minus k quantity squared over y. Okay, why did I x squared? I meant a squared and b squared. Has to equal 1. If the a squared term is the larger of the two, always, and it's underneath the x squared, which way is this shifted? Horizontally, so this is a left and right one. And then the vertical one is when the a squared is underneath the y value. So it's just x minus h quantity squared over b squared. Where a is still the distance from the center to vertex, b is still the distance from the center to the co-vertex, c is still the distance from the center to the focus, foci, thank you, and h and k is the center. What's going to happen here, guys, is just instead of starting at 0, 0 and walking left and right, plus 7, minus 7, we'll start at 1, 2 and have to add 7 and get 8, subtract 7 and get negative 6, things like that. It's just a matter of being able to plot it in space and know how to count. I'm asking a lot. Instead of starting at 0, we might start at like 4. Okay?
That's a struggle.
It's a lot. But you can do it. You can do it.
I'm doing it.
All right. Quitting while I'm ahead.
I love that movie.
So let's start with this. We have the quantity x minus 3 squared over 25 plus y plus 6 quantity squared over 49. Then it all equals 1. So our starting point here is still the same basic idea. We're going to identify everything. We're going to plot it, graph it, do all the stuff we possibly can, and have a great old time.
No, that's what they tell you.
So where is your center going to be located on this problem?
-3.
Whoa!
3
negative 6.
I'm sorry.
The center is going to be at 3, negative 6. My a squared is 25. My b squared is 49. C squared is going to be, excuse me, wrote that wrong. 49, 25. C squared would be 49 minus 25, which is 24. Good. So therefore, my A values are going to be plus or minus 7. My B values are going to be plus or minus 5. And then my C value is going to be plus or minus, very good, 2 root 6. What direction is this being stretched? Horizontally or vertically? Why is it being stretched vertically?
Because the bigger number than the y value.
Very good. So we should do the picture, and we know what we're doing. Hopefully, ish. And plot. Center is at 3, negative 6. Now we have to walk to our vertex. Our vertex, the distance from the center to the vertex is the value of A. Our value of A is plus and minus 7. Since we know that it's being stretched vertically, do I go up or do I go left or do I go right or do I go down or what do I do? Up and down 7 from there. So if I go up and down 7 from here, well, here's 6, So one of my vertices, my vertex would be at 3 and 1. The other one would be at 3 and, well, what's negative 6 minus 7? Negative 13, very good. What we're doing here, guys, is we're adding and subtracting 7 to the y value, because it's got to go up and down. We add and subtract to the x value to move it left and right. So the other one would be down here. So 6, 7, 8, 9, 10, 11, 12, 13. Okay. Go to the covertex. The covertex, I have to add and subtract 5 to the x coordinate because I'm moving it horizontally. So if I add 5 to 3, what do I get? 8. If I subtract 5 from 3, I get 2, -3. So my covertices are, negative 2 and negative 6, and 8 is negative 6. What am I forgetting to put in? The foci. The foci, if I'm stretched vertically, what direction do the foci go? Vertically. So that means my foci, this over a little bit. My foci, I know that the x coordinate won't change because it's going to be on the same vertical. So it's still going to be at 3, 3. But to the negative 6, I have to add 2 root 6 and subtract 2 root 6. So how do you write that? You write negative 6 plus 2 root 6 and negative 6 minus 2 root 6. And you just put dots and just call it a day. Okay? Really, that's about all you can do with that. I mean, you can...
Where'd you get the 6 from? That's where it starts.
Remember, we got the value of c. The value of c came from that 24. The square root of 24 was 2 root 6. The distance from the center to the focus, if my center is at 3, negative 6, my focus has to go vertically. So I'm adding and subtracting from the y value. So I'm adding 2 root 6 to the negative 6, and I'm subtracting 2 root 6 from the negative 6. I don't care what that decimal is. I really don't. This is a nice exact answer. And it tells me exactly where it's going to be. And that's it. I mean, I say it, oh, that's it. But do you notice it? I mean, it's the same thing we did yesterday. Instead of adding and subtracting from 0, this time you had to add and subtract from 3 and from negative 6.
Not bad.
So it's not as scary as it looks god-awful.
It does.
It does.
It's like half a sheet for one problem.
Right? It can. But like I said, it's... When we get to the completing the square parts, that's when you get really mad at me. But that's okay.
No, I'm gonna quit. I'm quitting.
It was negative 6 minus 2 root 6, negative 6 plus 2 root 6. All I did was just tack on the c value. That's it.
Wait, I have a question.
Yes, ma'am. Shh. Sorry, what was that? Oh, I just put a couple of dots. I mean, you can find the decimal equivalent if you want, but in my world, if you put a couple dots in there, I'm happy. I'm more concerned that you actually give me the real value. I'd much rather see that, because I know that you know what you're doing. I know that you know that I know that you know that you know that I know that you know what you're doing.
Are the points always going to be equal to 6 from the center?
Yes. Good question. Are the points always going to be equidistant from the center?
Yes.
Yes.
Yeah.
Absolutely, and that's going to come into play here in a little bit. What's up? Yeah. You can type it. You don't have to. That's the vertical spot. If you want to know exactly where it is, you just type in 6. Oh, excuse me, negative 6 plus 2 root 6 and get a decimal. So it's at negative 1.1. That's all it is. That's why I'm not really so concerned about the placement of it, because it really doesn't matter in the grand scheme of things, because you're telling me specifically what it is, and that's okay. All right, we're not doing the approximations, not doing the issues. We're doing there it is. Okay. All right, so let's jump from that to write the equation of the translated eclipse. Eclipse. Ellipse. It's not a Mitsubishi.
Where'd that voice come from?
So you have foci at 3.
This.
Oh man. And vertices at 3, 6 and 3, -2.
Wait, I have a question. Real quick.
Yes, ma'am.
So is the foci always going to be just whatever H and K is, and then what C equals?
Maybe. Remember, the foci is always going to be on the same line as the vertex, whether it's horizontal or vertical. They will always share a vertex, or an H or a K, or an X or a Y. Yes, sir.
Alright, so you know how like to get the focus, you like do the vertices and the co-vertices and
Yeah.
you subtract them.
Yeah.
If those two are both like perfect root, like square roots, and then will the foci ever be perfect square roots? Or will
It can be. It doesn't necessarily have to be. A lot of times, you can get all 3 values being perfect roots. It does happen, and it does happen a lot of times that 2 out of 3 aren't, or all 3 of them aren't. I mean, it's a crapshoot. It really depends on the numbers. That's all. A lot of times they're trying to give you at least a couple of the A's and B's, or at least one of them to be a perfect root, because it's a little bit easier to start with. But it doesn't necessarily always have to be that way. Okay. It still works either way. Here we've got a foci and a vertex. So what I'm going to do, like we did yesterday, is plot it and figure out what direction it's going. And from there, like Alicia was just saying, it's going to be, we use these values to figure out where the center is located, because the vertices are equidistant from the center. The foci are equidistant from the center. The co-vertices are equidistant from the center, because they have that same A value, same B value, whatever it might be, the C value. They're the same things going in the same direction. So what you're going to wind up doing here a lot of times is finding midpoints. Okay? So watch what happens here. We have foci and vertex. Foci at 3, 5. And 3, -1. That should tell you something right away. Oh, it should tell you that I graphed it incorrectly. Now it should tell you something right away.
so confused when you did that.
What does it tell you?
It's going to be
What direction it's going?
It's going vertical.
It's got to be vertical, because if the foci are vertical from one another, that means it has to be vertical. So we know right away it's got to be vertical. So then I plotted the next point. My next points are my vertices. My vertices are at 3, 6 and 3, -2. So obviously now, it has to be vertical. Right? So now here's what we do. First thing we're trying to figure out is, where is the center located? Does everybody agree that the center is going to be located at 3, something?
Yeah.
Yes. The reason that is because these guys are all on the same vertical line. So I know the center has to be at 3, well, all we have to do is find the midpoint of the y values. So what's 5 plus -1?
4.
What's half of that? 2. Where's your center?
2.
And now the toughest part of them all, counting. How far is it from center to focus? Well, 1, 2, 3. C is 3. Center to vertex, 1, 2, 3, 4. A is 4. Therefore, we can figure out C squared, A squared, and figure out B squared. So C squared is 9. A squared is 16. To find B squared with ellipses, so 9 is 16 minus what? 7. So B squared is 7. Now you have all of your information. When we go back to write this in, we know that the A squared's got to go underneath which part?
Y.
Y, because it's stretched vertically. So you wind up with, well, x minus 3 quantity squared over our b squared, which was 7, plus y plus 2, oh, excuse me, y minus 2 quantity squared, and a squared was 16, and equals 1. Now, Kobe, you see how that worked out where you wound up with two values that were easy to square root to square back and forth, and it gives you one that isn't?
Yeah.
It happens. You know, I'll have ones in here that you'll have square roots to start with distances, but once you square it, it's a values is just walking. Okay. Was that frightening?
Yeah.
Sort of.
Not yet.
These are the ones that take a little bit longer to do.
Yeah.
No, yes.
Let's do it.
No, we don't want it. Now it's not gonna- Alright, this is actually the whole layer.
Dun dun dun! What's that?
I'm dropping out of school.
A lot of them do, and that's the thing. The Algebra 2 book tries really hard not to give you guys awful ones. You're gonna see a lot of 9s, 4s, 12s, 36s, 49s, 64s, numbers that work pseudo cleanly because it's easier to take square roots. It's easier to plot. Don't get me wrong. I may or may not have some nasty ones that I'll give you eventually, but
Please don't.
it's just algebra.
Is this like that square thing, the proof?
Yeah, this is the complete the square one. So in order to classify this one out, what we need to do first of all is basically group stuff together. So I'm going to get the x values together, the y values after it, and then I'm going to move the constant to the other side to prepare to complete the square, not once,
But twice.
but twice.
No.
I'll show you.
I don't know.
So right now you should have that written down. Yes. When you go to complete the square, the first term of your x squared value always has to be 1. So what I'm going to do here is I'm going to factor out the 9 in the x's, and I get x squared plus 4x plus blank plus 4 y squared minus 6y plus blank. And now that has to equal the negative 36 plus, remember what we had to do with the circles when you had that coefficient? What did we have to do? We do blank blank, but what do I do to the blank?
9 times
Yeah. Remember, this is what comes up now. When you're completing the square with a lot of these conics, a lot of times that first term is not going to be 1. Since we're not dividing it out because it's not equal to 0, we have to make sure we put back in 9 times the blank plus 4 times the blank. Okay? That's the one thing you've got to make sure you remember. By now, I think completing the square has kind of become old.
It's pretty fun now.
Second nature, I hope.
For really long, I'm already
So we have half of 4 is 2, which means the term is x plus 2. Bring the 9 with it. I square the 2 and I get 4. 4. I brought the 9 down because I bring it still in front of the parentheses there. I do the exact same thing with the negative 6. Whoa. Oh.
That's third. Oh, wow.
What's half of negative 6? Negative 3. So it's y minus 3. I square it and I get 9 over there.
So is that a coincidence?
It's coincidental.
It's 36.
It equals 36. So now we're almost into perfect. What do you have to do?
Get rid of the 9 and 4.
Get get the 36 to 1.
Get the 36 to 1 by not subtracting 35.
Divide by 36.
Divide by 36.
Divide by 36.
This is too much.
This gives you values of A and B. This is what differentiates a circle from an ellipse. Notice what happens when you divide out by the 36, you get two different denominators. You get x plus 2 quantity squared over 4, and then y minus 3 quantity squared over 9. If those A and B values were the same, you would have a circle.
Why is the 4
Okay. That's actually not so bad.
It really isn't. I mean,
That's
There's
it.
a lot of writing.
well, you can graph it.
No.
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 Well, you will be eventually.
I could graph it.
I know.
Wait, we are eventually
we
going
know
to
we
graph.
know.
Which way is
I
this?
have it certain
Which
on
way is
paper.
this? Which way is this one stretched?
Very close.
about 2 pages.
Why?
Okay.
And that's it? We don't have to write anything on the center and all that.
That was 2 problems.
There was another.
We don't have to do it, it's fine. I sent 3 other, 2 other notebooks.
I don't know where the other one was. Let's try this one last time. I have an ellipse with foci 2, -4, 5, -4. Vertices -1, -4, and 8, -4. Hopefully.
Know which way it's going.
I don't know.
Just like we did earlier, we plot it just to get an idea. Ah, what way is it going? I think from now on, we always have to make the sound effect.
I keep you okay with that.
Okay.
It does.
And then we have vertices at -1, -4, and 8. Okay. Now the tricky part. How are we going to figure out where our vertex is? We know which value for the vertex. Not vertex, excuse me, center. I meant to start at the center. -4 is going to be my y value. But my x-coordinate, I have to find the midpoint. I have to find the midpoint of 2 and 5, or find the midpoint of -1 and 8. Either one of them is going to be fine. So what's 2 plus 5?
7.
What's half of that?
3.5. Can't you just count the space in between 2 points?
Yeah, can we play Monster Squeeze?
You can do that if you want, I don't care, but all I'm saying is that you'll have decimals sometimes.
What did he say? I'm not made.
So now the distance then, how far apart is 5 from 3.5? 1.5. So my C value is 1.5. My A, whoa. My A value, well, how far away is 3.5 to 8? 4.5. So you'll notice that you will have to deal with some decimals and or fractions with some of these things. They do get a little ugly. But you got a calculator, it's not that big of a deal. If this was the case and I didn't let you have a calculator to do some problems, which I'm known to do,
Don't do it.
I would not give you a decimal that you'd have to figure out. I mean, you could square 1.5, it's not that bad. I mean, what's 15 squared? Move the decimal twice, you get 2 1/4. Okay. So basically what I'm saying here is you know that's going to be stretched left and right. Your center is there, so it's going to be x minus 3.5 20 squared plus y plus 4 20 squared. Which one will get the a squared value? The x. So whatever 4.5 squared is here.
20 and a fourth.
What is it?
20 and a fourth.
20 and a fourth, thank you. And then our b squared term, well, we have to figure that out.
It comes out as a whole.
It's weird, isn't it? So your c squared was 2 1/4. Your a squared was 20 1/4. So 2 1/4 is 20 1/4 minus something.
2.5. Just kidding. I did it wrong.
What's going on?
Oh my god. It comes out as a whole number.
I'm trying to find.
2a minus c. 20.2.5 minus 2.5.
22 and a half.
This is your.
Pretty sure it's 22 and a half.
Yeah, this is supposed to be 18.
So 20 1/4 subtract 22 1/2 gives you 2 1/4.
Come on.
Let's rephrase this.
18.
Awesome.
2, yeah. For the love of God, it's 7. 2 is 20 minus what? 18. 2 1/4 is 20 1/4 minus what?
18 and a quarter. 22 and a half.
I've had 8.
I'm searching.
That's why I just did
I
I still have no
I
idea.
like this class. I just
I have no idea. I just added the 2 numbers that are on the board. Just like last year. I barely added this one.
I was like, why is this not working?
Minus 18 is 2.25. Do those, please.
That was just. I needed that laugh.
Made my brain hurt.
Sorry.
I needed that laugh.
You guys killed me. Wait, I don't know. 7. I don't know. Wow. Let's see. So this is, make sure these are good. 17, 18, those are all right. 24, 25, you're just graphing, labeling all the parts. Okay. 54, 55, 58. 54, 55, 58 says classify and write, stand for, and graph. So 54, 55, make sure you're going to have to do the completing the square stuff and then label it, graph it, and label it out. Okay?
Gotcha.
Okay. I need to listen.